Welcome to the second video. So in this one now we'll be dealing with indices that involves the exponential equations. So just like I did previously, with this one I also have to give you a basic introduction of exponential equations. So you have to know that exponential equations are in the form of a to the power x is equal to b. So meaning that you are going to have a quantity here raised to the power, and then they'll say that it is equal to something. So something like that, you have to know that it is an exponential equation. So when you are solving these exponential equations, your aim is to make sure that these things are the same. So let's say, for example, you have been given 2 to the power x is equal to 4. Then you have been told to solve for x. So solve for x. So to solve for x, you have to make sure that there should be a 2 there as a base. So here you already have a 2, so you are going to bring 2 to the power x should be equal to here where there's a 4. You are going to ask yourself, what can you do so that you have a 2 as a base? Or what can you replace with here that has got a 2? So you can replace with a 2 squared. So 2 squared is the same as 4. So when bases are the same, you cancel them now. So you equate what has been left. So you're going to say x is equal to 2. So that becomes your answer. So this is the basic idea behind the exponential equations. So let's now dive into the examination questions. So for this one, don't have a lot of things to talk about, but to just go straight into the exam questions. So for the examination questions, we have got 8 of them. So we have got 8 interesting questions. So let me see solutions here. So the first question, the first one, it was taken from a GCE paper for 2017. So here you have been told 25 raised to the power x should be equal to 5. So you check between 25 and 5, which one is small. So 5 is small, so you should aim to have 5 in this side where there is 25. So what can you do to have a 5 here? So you're going to ask yourself, which number when raised to a certain power will give me 25? So the number that we are talking about here is 5. So when you do 5 squared, so 5 squared is the same as 25. So you replace every part where there is 25 with 5 squared. And remember, this one was raised to the power x. So that x, you don't neglect it, but you put it in brackets like that, x. Then should be equal to, and then here you bring this 5, so 5 there. So you cancel the bases here. If there is nothing on top, just know that is the same as to the power 1. So you cancel this 5 and that 5. So you equate what has been left. You have got 2, and then open bracket, x is equal to 1. So this is the same as 2 times x, which is 2x is equal to this 1. You are finding x, so you divide both by 2, so over 2, and there over 2. Then you cancel. Your x now is 1 over 2. So proof now. So for those who are getting the concepts, you can also prove using what I did in the previous video. You know that here you have got 25, and then x is on top. So you have found that your x is 1 over 2. So this is proof. So where there is x, you can put 1 over 2. So 1 over 2 as a power. And I said that anything raised to the power half is the same as the square root. So this thing should be equal to 5. So here, when you find the square root of 25, it will be 5. So this tells you that your answer is correct. But you are not required to prove in the exam. So that is question 1. So let's go to question 2. So question 2, we have got, so this question 2 was brought in 2018 internal paper. So we have been given x raised to the power 1 over 3 should be equal to 4. So those who were following, you know that this is the same as cube root of x. So but here you are not going to use the concept of cube root, because if you put cube root here, it will still not help you with anything that side. Your aim is to find this x. So what you have to do here is you have to make sure that you cancel this power. So to remove this power, you can multiply by the multiplicative inverse of this. 1 over 3, its multiplicative inverse is 3 over 1, so which is just the same as 3. So you multiply times 3 here, and you also here, I said you have got e to the power 1 if there is no number. You can also multiply times 3 there. What you have done here is also what you should do there. So here you have got 1 over 3 times 3. These ones, they will cancel, so you are just going to have x to the power 1, which is the same as x, is equal to, then here you have been left with 4 to the power 1 times 3. The answer is 3. So x will be equal to, so 4 times 3 is the same as 4 times 4 times 4. So 4 multiplied by itself 3 times will give you 64. So x is equal to 64. That is your answer. So the way you can prove that also, you can put 64 here and you find the cube root of 64. The answer will be 4. So that's how you know that your answer is correct. So that's how you deal with that one. So that is question 2. Let's go to question 3. So for question 3, you have been given 8 to the power x should be equal to 128. So this one came in 2019 internal paper. So to do that one now, what you have to do is you have to make sure that the bases here are the same. So you can think of the lowest base. Do you know any number whereby when you raise any number like 8, when you raise it to the power what for it to give you 28? So you might struggle to find it. So you can just reduce this 8 if it is reducible. If there is a number in both sides, there are numbers which are reducible, you can reduce. So what you can do here, you can look for a number for both. You can say 2. So for 2 to give you 8, it has to be 2 to the power 3. So 2 to the power 3 is 8, because it's 2 times 2, which is 4, and then 4 times 2 is 8. And then there is already x there, so you put that x here. So x should be equal to, if you have put 2 here, also put 2 there. Now the question is, 2 should be raised to the power what for it to give you 128. You have to know that when you raise the 2 to the power 7, that's when it can give you 128. So you can even prove that by doing it on a piece of paper. So here you have seen that the bases are now equal, so cancel them. Then here you have been left with 3 and x. So when you do 3 times x, the answer is 3x is equal to, and then here you have got a 7. So you want to find x, so you divide both by 3, also here 3, then you cancel. So your x will be equal to 7 over 3. So this one can't go there without a remainder. So if you want, you can leave it as a mixed fraction. So 3 into 7, it goes there 2 times, and then remainder 1. Then the denominator remains the same, which is 3. So this becomes your answer. So once you have done that, it means you have solved question 3. So let's go to question 4. So for question 4, you have got 8 to the power x minus 1 should be equal to 16. Same thing like there, you need to make sure that you have got equal bases here. If you use 8 here, you cannot find a number raised, or you can't raise 8 to the power a certain number to give you 16. So this tells you that you have to use a different number. So let's use 2 again. So 2, for it to give us 8, it should be raised to the power 3. And then this one, x minus 1, is already there, so bring it, but put it in brackets now. So x minus 1 is equal to this side. You can also use 2, since you have used 2 there, and you want the bases to be the same. So for 2 to give you 16, it should be raised to the power 4. So that 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. So this is the same as 16. Bases are equal, cancelled, equate what has been left. So you have been left with 3, open bracket, x minus 1, close, is equal to 4. So 3 times x, it is 3x. Minus 3, you know that 3 has to be multiplied by everything to remove the brackets. So 3 times 1 is 3, then is equal to this side, you have only 4. So this 3 has to cross and go there. So you are going to have 3x is equal to 4. Then when this 3 go there, it will be positive 3. So 3x will be equal to 4 plus 3, which is 7. So over 3, then you cancel. So your answer will be 7 over 3. Now this 7 over 3 as a mixed fraction, we know that it is 2 as a whole number, then 1 over 3, just like there. Yes, this is your answer. So these things are very simple. So I can go to question 5. So question 5 now. So for question 5, you have got 125 raised to the power x should be equal to 1 over 25. So for this one now, you have to deal with this part which is here. So to deal with this part, you have to remember the idea of negative powers. So for negative powers, remember we said that something which is like, let's say 25 to the power negative 1, this is the same as saying over 1, then 1 goes on top, and then this one comes down, and then it will bear a positive power. So you're going to have 1 over 25 to the power 1. Now 25 to the power 1 is the same as 25, so you have 1 over 25. So in short, 1 over 25 is the same as 25 to the power negative 1. So this is what we will do now. So this part where there is 1 over 25 will replace with 25 to the power negative 1. So 125 to the power x will come like that, should be equal to 25 to the power negative 1. So you look for a number. So raising 25 to a certain power so that you get 125 will be difficult because you can't find that number. So you can use a small number. So for that one, let's use 5. So 5 should be raised to what power for it to give us 125? It should be raised to the power 3. Then this x, you bring it like that. X should be equal to, here we have got 25. So 5 should be raised to the power 2 for it to give us 25. So 5 to the power 2 is the same as 25. Then this negative 1, you bring it, but in brackets, negative 1. So 5 and 5 cancelled, you are going to be left with 3x is equal to 2 times negative 1, the answer is negative 2. Then over 3, then you cancel, so your x will be equal to negative 2 over 3. So this is an improper, this is a proper fraction, so you leave your answer like that. So this is question 5. Then now we can go to question 6. Question 6 is simple. You have got square root of 2 should be equal to 2 to the power x. So you can deal with the square root. Remember, this also comes back to this. I told you that anything raised to the power 1 over 2 is the same as the square root of x. So in short, the square root of x is the same as x to the power 1 over 2. So this means that this one, square root of 2 is the same as x to the power 1 over 2. And then should be equal to 2 to the power x. Let me not put x here. Let me put that 2. So it's the same as 2 to the power 1 over 2. Now this 2 to the power 1 over 2 should be equal to 2 to the power x. Let me write it properly. So you have got square root of 2, which is the same as 2 to the power 1 over 2, and should be equal to that 2 to the power x, which we have of 2 to the power x. So you see, upon just rewriting this, just after rewriting square root of 2, the bases are already the same. So what does that tell you? You cancel them and equate what remains. So what remains here is x, here is 1 over 2. So your 1 over 2 is equal to x. So this is the same as writing, saying x is equal to 1 over 2. So that's your answer. Let's continue now. So this is now, this was question 6. And then we can go to question 7. So, and you can see the years on which these questions were brought. I've indicated them here, so that you go and confirm on the past papers and see that indeed these questions have been taken from past papers. And then this one, which is here, I didn't indicate the year, but you have to know that it came in 2024. So this one, the last one, it came in 2024 GCE. So 2024 GCE. Okay, so let's solve. So I ended on question 6. Let's go to question 7 and question 8. So question 7, it came in 2022 GCE. We have got x raised to the power 1 over 3 should be equal to 9. So this is the same idea with question 2. So if you understood question 2, it means you can solve question 7 on your own. So we have got question 7, which is saying that x to the power 1 over 3 should be equal to 9. So with this one, we also do this. We know that this means the cube root of x, but since we want to find this x, so we multiply everything by the multiplicative inverse or the reciprocal. So 1 over 3 is reciprocal is 3 over 1, and 3 over 1 is the same as 3. So you do times 3 here, and there also times 3. You know that there is a 1 here if there is no number. So 1 times 3. So 3 and 3 will cancel. X to the power 1 is the same as x, and then is equal to 9 to the power 1 times 3 is 3. So 9 to the power 3. So x will be equal to, when you do 9 to the power 3, that is your final answer. So 9 to the power 3, it means 9 times 9 times 9. So 9 times 9, your answer is 81, and then 81 times 9, the answer is going to be 729. So your final answer is 729. So you can prove it by doing this. You can put 729 there on x, then it will mean cube root of 729. So cube root of 729 is 9. So this confirms that this is the correct answer. So question 7 is done. Let's go to the last one, question 8. So question 8 now, we have been given 81 minus 27 raised to the power x should be equal to 0. So when you look at this one, it came in 2024 GCE paper. So for this one, you have a 0 there. You go and take this and put it there. So you have got 81, which will remain here, should be equal to, this one is negative. When it goes there, it will be positive 27 to the power x. So once you have done this, make the bases to be the same. So 27, raising it to a certain power to give you 81, it will be difficult for you to find that. So look for a small number. Let's use 3. So I'm going to put a 3 here, should be equal to, even there I also put a 3. So I'll ask myself, 3 should be raised to the power what for it to give me 81? You have to know that it has to be raised to the power 4. So this 3 to the power 4 is representing 81. And then here 3 should be raised to the power what for it to give me 27? It should be raised to the power 3. So this 3 to the power 3 is representing 27. And then I already have an x there, so this x I put it. Don't neglect it. Then now the bases are the same, cancel them. 3 cancelled, 3 cancelled. So you have 4. 4 is equal to 3 times x, the answer is 3x. So your job is now to divide both by 3. So you cancel. So your x will be equal to 4 over 3. Now 4 over 3, writing it as a mixed number, it will be 3 into 4 is 1, remainder 1, and then over the same 3. So that becomes your x. So that is how we solve exponential equations and indices. So thank you very much for watching. Goodbye.